Chaurasia, to this very important session of math club, math club or math math lab at the schools. Some schools call it math club, some schools call it as math. So various names, but the idea is how to effectively have some kind of activity sessions which can keep the interest of students. And so we'll go by the name of Math Lab because students take more seriously if instead of a club, it is called a lab. Okay. So I request Professor Praveen Chaurasia to start his session. Please.
Thank you, sir. Thank you, Professor Rana, sir. Actually, it's a great pleasure that you have invited me just to discuss with the respected teachers regarding the concept of mathematics lab. It's my pleasure that we have a long association with Professor I.K. Rana and this maths for all activities. We have a long association, and after a little gap, I am just discussing with you people about the concept of laboratory. Everyone knows about that. CBSE has already issued guidelines regarding mathematics laboratory in each of the schools, and there is a few psychological importance of having mathematical laboratory in the schools also. I will be discussing in detail about the why we need the mathematics laboratory and what are the concept, what are the ideas behind the mathematics laboratories, what are the things the people had visualized earlier so that this concept has been introduced in the schools. So I will be discussing in length. So first of all, I would like to, I just start sharing my desktop. I hope everybody is now able to see the desktop. So as told earlier, the title of the today's discussion is Concept of Mathematics Lab. So I would start with this one of the concept, that area model. We are discussing this concept with the students since primary section itself. I mean, in the latest this NEP 2020, there is no such a primary things now, but we have a foundation, then preparatory stage is there. So at the preparatory stage, we are discussing about this area model, and we are using this area model for several concepts. First of all, I would like to I am exploring some of the concept which we need, and how this simple concept is very helpful from generalization of arithmetic into algebra also. We will see all these things. I will not take much time, but I will start with some of the things here. I've taken one of the this basically at very early stage we start about the exploration of the area concept. We give we provide students this type of chart paper, and we are expecting that the students will be able to calculate the areas, and at this later on when we move further, we start we are just giving the participations of the areas and different part. We are expecting that the student would be able to recall this different what are the dimensions of different areas, and in collectively how can we see these things, all these things. So in while exploration, these things are there. In the generic mode, we are able to see that if we are looking that we have suppose we can here there is possibility that we can change the dimensions of this area model, and suppose I have taken 2 × 2 only, and then we can put any of the dimensions here, and then we can expect that what the students are noticing about the area of different sectors and what is the relationship between them. So such type of expectations we do when we start, when we do such type of experiments with activities we perform with the students, we are performing such type of activities. Moving further, when we are introducing variables, I when again this area model is we are using for the introduction of the variables, and this algebraic identities type of things we are using it. So we can take anything. Suppose I have taken 7x here, and I have taken 5 here, and then again here I have taken some 5, and then I have taken again some 6. So an algebraic expression, such type of an algebraic expression would come, and we are able to predict such type of things here. Basically, there is a guide, there is a tutorial for this exercise. Let me show you this tutorial first, and then we'll move further. Just give me 1 second. This area model, I would like to show you one small video clip regarding that, which is the tutorial of this this area model concept, which I was just discussing with you people.
Uses the model grid. The generic and variable screens use a model that is not to scale to generalize the use of an area model. And the game screen is a fun way for students to test their understanding of an area model for distribution and factoring. The Explore screen is useful for reminding students that an area model is one model for thinking about multiplication, and that the total area is summative. You can drag the corner handle to make any size rectangle, and partition the area rectangle into partial areas, creating up to 4 partial areas. Students can see the dimensions and the total area reflected in the area model. After students turn on partial products, I would ask them to determine the relationship between the 4 partial areas and the total area. You can view the factored partial products to help coordinate the area calculation with the model. In particular, we want students to notice the second line in the calculation. So I would ask students to determine the relationship between the first and second lines in the calculation and how they correspond to the area model. The generic screen is about transitioning students away from thinking of multiplication as units of area and generalizing the process of using an area model to multiply multi-digit numbers. To create an area model, you can choose the size from the drop-down menu and build the model using the keypad. The process of entering numbers makes it explicit to students that they should be partitioning with place value in mind. After creating a multiplication problem, I can ask students to determine the product of 5 and 23 using the partial products, before revealing the total area of the model. In the generic screen, notice that the second line in the area model calculation illustrates the distributive property more explicitly than in the Explore screen. Variable screen is an extension of the generic model seen on the previous screen. The difference here is that the keypad allows students to enter x and x squared terms to build a multiplication problem involving algebraic expressions. This screen can be used to extend a model that students are familiar with to something new and abstract. I might first start by asking students to build multiplication problems that have x somewhere. to find similarities between multiplying numbers and multiplying with variables. Once students are comfortable with an area model as justification for multiplication of algebraic expressions, you can introduce the concept of factoring using an area model. To do this, I would challenge my students to find a 1x2 model with a total area of 2x plus 12. Students use guess and check as a strategy, while others might develop more sophisticated methods for answering this challenge. After students generate responses, I would facilitate a class discussion around the various strategies and responses. When your students are ready for a challenge, encourage them to head to the game screen. There are 6 levels that increase in difficulty. The teacher tips have more detailed information about the types of challenges in each level. Levels 1 through 4 ask students to find missing parts of an area model, while levels 5 and 6 are explicitly asking students to factor. So in level 1, you might be finding a missing partial product or the total area. Note that a correct answer on the first try earns 2 points or 1 star. On level 6, you are given the total area and must determine the factors. Note that a correct answer on the second try earns 1 point or half a star. Depending on what I'm teaching in my classroom, I would specify the levels I want students working on first, then allow them to work on other levels if they are interested. Remember to check out the teacher tips and teacher submitted activities for more teaching ideas.
So this was, I had just discussed on this video primer of area model. My focus was that actually what in the mathematics laboratory, there are 2 things which we have to notice. I mean, it's a need of the hour that there are 2 terms in from the education point of view we are looking, we are asking about. There are 2 types of thing available, that is teacher centric and learner centric. So this model appreciates that if we are developing some model, this can be done by hands-on activity also. And lots of teachers I know, they are performing these activities in the classroom. But the problem is that if everything is the teacher centric, then the impact of the activity is not up to that level which we are expecting. So how to create the things from the, I mean, if we are creating something for the learners, how we can go for the learner centric things. This is just one of the example I wanted to show you, and I just discussed with you. I just shown you a demo video regarding that. If we are creating any activity in a very sensible manner, that we have taken very basics of area concept, that is we have taken the just product of 2 numbers, then we are coming to the generic thing, then we are coming up to the variables thing, and then accordingly we can create some puzzles games also regarding this concept. So this such type of things we can think of on different concept of mathematics. Now moving further, this is if I some of the questions we need to refer at this moment if I am discussing about the concept of mathematics laboratories. So these are few concerns I am referring here, that many students in our schools even today show displeasure towards the learning of mathematics. Everyone accept this thing. Students view mathematics as dull, boring, and stereotyped. All this whatever the things I am mentioning here, this is just this has come with the discussion from the teachers, this has come with the discussion of the students. Most students think that mathematics means to get something right or to get something wrong. The students are just referring that either we are getting some correct thing or we are getting something which is not correct. And when they get it wrong, they think that they are not good enough for mathematics and lose interest in learning. On the other hand, a few students learn enough tricks to get something right to pass the exam. There are not enough instances when a teacher has tried to teach maths in a different way, say through activities and games. These activities and games make the process of learning more interesting and effective. The setting up of a mathematics laboratory adds these efforts. Now, I am talking about creating environment. How we can create the environment if we are looking the environment which involve the student. I mean, which create the students' interest also. So we are looking to creating environment. A mathematics laboratory is a place where we find a collection of games, puzzles, teaching aids, and other materials for carrying out activities. These are meant to be used both by the student, by their own, and together with their teacher to explore the world of mathematics, to discover, to learn, and to develop an interest in mathematics. The three important words is to discover, to learn, and to develop an interest. Although mathematics is not an experimental science in the way in which physics, chemistry, and biology are, a mathematics laboratory can contribute greatly to the learning of mathematical concepts and skills. I will be discussing in much length about it. I am just talking about creating environment. Mathematics lab is a mean of creating some environment. So what is the definition of mathematics lab then? This is a standard definition of the mathematics lab, that mathematics laboratory is a unique room or place with relevant and up-to-date equipment known as instructional materials designated for the teaching and learning of mathematics, whereby a trained and professionally qualified person, that is mathematics teacher, readily interact with the learners, that is students, on a specified set of instructions. Laboratory method is commonly used today to refer to an approach for teaching and learning of mathematics, which provides opportunity to the learners for connecting abstract mathematical ideas through their own experiences, that is to relate symbol to realities. Basically, everybody as a mathematics teacher, we are knowing that mathematics is an abstract concept, and mathematics lab, the mathematics lab is a place where the abstraction of the mathematics concept is being reduced. We are trying to reduce the abstraction of the mathematics concept by using the mathematics laboratory, and we are trying to concretize the things in such a manner that the concept should be should be felt with the concrete objects itself. Now I would like to show you one more demo video here, and this video is from Professor Arvind Gupta ji. He was director of HBCSC, and his one of his this motivational. This is a very short video. I'm just showing you, and actually he has given a lots of motivation in this video. And from the mathematics teacher's point of view, I personally like this small video a lot, and that's why I am just showing you this video here. That from the, I mean, if we are talking about teaching and teaching learning of mathematics, what should be the approach? And here he have given a very good, nice deliberation here, and I am just playing his video just so that you can also get this motivation from this video itself.
Praveen. Hello, Praveen.
Yes, sir.
There is no audio in this.
Is it? Earlier we are getting audio.
No, we are not getting.
No, in previous demo.
No, previous it was there. In this, there is no audio coming.
Okay, sir. Just I am coming.
ये मैं आपको एक छोटी सी एक कैलेंडर है, पिछले वर्ष का कैलेंडर है। ये किसी भी साल का कैलेंडर हो सकता था। हमारे आसपास स्कूल के अंदर, घर के अंदर, ऑफिस के अंदर हर जगह कैलेंडर होते हैं। हम रोज कैलेंडर देखते हैं और देखने के बाद में भी नहीं देखते हैं। विज्ञान का मतलब है हर चीज को बारीकी से उसकी जांच परख करनी, उसका अवलोकन करना। अब मैं आपको यहाँ पर कुछ नमूने हैं एक कैलेंडर के अंदर, उनको दिखाता हूं। ये कोई मई है। 1 और 9 का जोड़ 10, 8 और 2 10, 2 और 10 12, 9 और 3 12, 15 और 23 38, 22 और 16 38, 20 और 28 48, 27 और 21 48। एक तरह का पैटर्न है, नमूना है। कभी आपने नोटिस करा? नहीं करा? नहीं करा। शायद कुछ मई में गड़बड़ हो सकती है। हम एक अगला महीना देखते हैं, कोई सा भी पलट देते हैं। 9 और 17 26, 16 और 10 26, 10 और 18 28, 17 और 11। हम ऐसा कर सकते हैं। हर एक के साथ यही आपको क्रॉस नंबर्स का जोड़ एक जैसा होता है। ये एक नमूना है, एक पैटर्न है। अभी हमने 2 बाय 2 यानी 4 अंक लिए थे। अब हम थोड़ा सा ज्यादा एडवेंचरस हो जाते हैं, एक थोड़ी सी बड़ी मैट्रिक्स लेते हैं 3 बाय 3 की। अब ये देखिए 3 बाय 3, इस मैट्रिक्स में कुल कितने अंक होंगे? 9 अंक होंगे। अब देखते हैं 2 और 18 20, जो 10 का दुगना। 16 और 4 20, जो 10 का दुगना। 3 और 17 20, जो 10 का दुगना। 8 और 9 और 11 20, जो 10 का दुगना। इन सब का औसत 10 है। कुल कितने अंक है? 9, और हर एक का औसत 10 है। इन सब का जोड़ कितना होगा? इन 9 का जोड़ कितना होगा? हर एक का औसत तो 10 है और 9 नंबर है, तो कितना जोड़ होगा? 10 into 9 90। झट से आप बता सकते हैं। तो यही विज्ञान का मतलब है कि हर चीज में एक पैटर्न देखना, अपने दिमाग को बर्बाद जानकारी से ओवरलोड नहीं करना। ये दिमाग बहुत ही कीमती है, बेशकीमती है। इसका काम है नमूने देखना, पैटर्न देखना, कॉमनैलिटी देखना, उनसे एक सूत्र निकालना, ना कि बेफजूल की जानकारी से इस दिमाग को ओवरलोड करना। ये विज्ञान का मतलब है। ये सत्य है विज्ञान का। अभी हम और कोई महीना ले लेते हैं। आइए, अभी देखिए इसमें हमें 4, ये कुल कितने अंक होंगे? देखिए, बोलिए। एक हफ्ते में 7 दिन और 4 हफ्ते कुल कितने हो गए? 28, 28 हो गए जी। अब देखिए इसमें पैटर्न देखिए। 4 और 31 35, 5 और 10 35, 5 और 30 35, 26 और 9 35, 6 और 29 35, 27 और 8 35, 7 और 28 35, 14 और 21 35। भाई 28 में कितनी जोड़ियां बनेंगी 35 की? 28 अंक हैं, 14। इस सबका जोड़ कितना होगा? 35 गुणा 14। कितनी मजेदार है, जादू भरा हुआ है कैलेंडर में। 30 साल पहले मेरे गुरु थे, आप उनकी किताबें जरूर पढ़िए। उनका नाम था पीके श्रीनिवासन। उनकी बहुत सी किताबें मेरी वेबसाइट पे हैं। उन्होंने सुंदर कि गणित, कैलेंडर में गणित है, झाड़ू की सीख में गणित है, दिया सलाई में गणित है, सिक्कों में गणित है, कागज में गणित है, हर जगह गणित ही गणित है। गणित का एक ऐसा रोमांच खरा। उन्होंने 60 लेख, एक हिंदू करके अखबार है जिसके लिए लिखे थे, जो मेरी वेबसाइट पे है, कि मैथ्स क्लब एक्टिविटीज। कितनी सारी हम चीजें कर सकते। अभी हम और आगे चलते हैं। अभी हम और कोई ले लेते हैं कैलेंडर। ये ले लीजिए। अब ये देखिए, अगर आपने इस पूरी एक रो है, इस रो का मैं जोड़ आपको, मैं इसको देख के बता दूंगा, इसका जोड़ 80 है। अब बताइए मैंने कैसे करा? मैंने जोड़ा तो नहीं, मैंने सिर्फ देखा। मैं एक सूत्र को देख रहा हूं, उसका मैंने मर्म पकड़ा है। 2 और 30 32, जो 16 का दुगना। 9 और 23 32 जो 16 का दुगना, इन सबका औसत कितना है? 16। सितंबर में कितने कितने सोमवार है? 5 सोमवार है, तो 16 पंजे 80। इसका कितना होगा? 75। अभी हम, ये तो हमारी रोज की बात होगी, अब हम खड़े कॉलम्स की बात कर रहे हैं। ये देखिए, अगर संडे 1 तारीख को है तो मंडे 2 तारीख को, मंगलवार 3 तारीख को, बुधवार 4 तारीख को। ये भी एक अंक गणितीय श्रेणी है, अर्थमेटिक प्रोग्रेशन। किसी किताब में नहीं लिखा होता, क्योंकि हमारे सब कागजी रट्टू तोता है कि ये अंक गणितीय श्रेणी हर कैलेंडर के अंदर होती है। कभी किसी आपके गणित के शिक्षक ने आपको ये बताया that arithmetic progressions are right there inside the calendar? अब इन सब का जोड़ कितना होगा कौन बताएगा? वही सूत्र है। हफ्ते में 7 दिन, तो एक बीच का दिन भी है 4। 1 और 7 8, जो 4 का दुगना, 2 और 6 8, जो 4 का दुगना, 3 और 5 8, जो 4 का दुगना। हफ्ते में 7 दिन, 7 चौका 28। इसका कितना होगा? 11 सत्ते। इसका कितना होगा? मुझे 18 का पहाड़ा नहीं आता, पर आपको आता होगा, आप बता सकते हैं। तभी अभी दिमाग को ओवरलोड नहीं करना, पैटर्न देखना, नमूने देखना, झट से उत्तर निकालना। विज्ञान का ये मतलब है, ये मर्म है। इसी के लिए मैंने आपको इसको दिखाया। बहुत ही सुंदर चीज है। हम आगे चलेंगे। मैं आपको एक कहानी सुनाना चाहता हूं। ये बहुत ही प्रख्यात गणितज्ञ है जिनका नाम था फ्रेडरिच गाउस। अगर आपने कोई भी, आप हाई स्कूल करें, कोई भी अगर कर्व प्लॉट करेंगे तो जो नॉर्मल डिस्ट्रीब्यूशन है उसका जो रेखा चित्र होता है, इस तरह का एक कर्व होता है, पहाड़ी जैसा कर्व होता है। इसको कहते हैं गॉसियन कर्व, नेम्ड आफ्टर फ्रेडरिच गाउस। अब ये गॉस के जीवन की एक असली कहानी आपको सुना रहा हूं। गॉस उस समय 3री कक्षा में पढ़ते थे और एक बार उनके टीचर ने कहा कि बेटा अपनी स्लेट निकालो। ये 350 साल पहले की बात। अपनी स्लेट निकालो और 1 से 100 तक की गिनती लिखो। तो बच्चों के लिए बड़ी आसान सी चीज थी, 3री के बच्चों के लिए 1 से 100 तक की गिनती लिखी। अब आप यहां समझ लीजिए, मेरे पास ब्लैक बोर्ड नहीं है, ब्लैक बोर्ड है भी। 1 से 100 तक की गिनती लिखी। उसके बाद उन्होंने कहा बच्चों से, तो इस तरह की गिनती लिखी। मान लीजिए। उसके बाद उन्होंने बच्चों से कहा कि आप इन सब अंकों को जोड़ो। शायद गुरुजी एक नींद लेना चाहते थे। बहुत से शिक्षक हमारे क्लास में आकर के सो भी जाते हैं अक्सर, क्योंकि क्लास ही इतनी उबाऊ होती है। तो उन्होंने बच्चों को एक स्कूल का वर्क दे दिया कि आप 1 से, तो बच्चे शुरू हो गए साहब। 1 और 2 3, 3 और 3 6, 6 और 4 10, 10 और 5 15, 15 और 6 21। अब आप देख रहे हैं कि जैसे ही अंक बड़े होते जाएंगे तो स्पीड बढ़ेगी कि घटेगी? घटती जाएगी। पर सब बच्चे लगे रहे। गॉस एकमात्र ऐसा व्यक्ति था जो टकटकी लगाए अंकों को देख रहा था। और गॉस ने क्या देखा? 1 और 100 का जोड़ कितना? 2 और 99 का जोड़ कितना? 3 और 98 का जोड़ कितना? 4 और 97 का जोड़ कितना? भैया अगर 100 अंक है तो कितनी जोड़ियां बनेंगी? 101 को 50 से गुणा कर दो तो ये उत्तर आ जाएगा। एक आधे मिनट के अंदर गॉस ने अपनी स्लेट पे इस उत्तर को लिख दिया। शिक्षक ने कहा यार मुझे तुझे सिखाने के लिए कुछ नहीं है, तू गुरु है, मैं घंटा लूं। असली शिक्षक वही पीएचडी की अपनी बात करते रहते हैं। आजकल पीएचडी बाद में हुआ, उससे पहले वो फॉसिल बन जाता है, क्योंकि जानकारी का विस्फोट हो रहा है। और सबसे बेहतरीन शिक्षक दुनिया का वो है जो कहे मुझे नहीं आता इसका जवाब, अपन मिलके खोजेंगे। मुझे जवाब नहीं आता इसका। आपके प्रश्न कल मैं देख रहा था, बच्चे तमाम सवाल पूछ रहे थे और बहुत से शिक्षाविद हैं, उनके जवाब खुद देने की शायद कहते तो मुझे उसका उत्तर नहीं मालूम, तो ज्यादा ईमानदारी का उत्तर होता। हमें नहीं मालूम उत्तर, बहुत सारी चीजें जिनके उत्तर नहीं मालूम, और हम शायद उनको मिलकर के ही खोज सकते। ये गॉस किसने, ये भी आपको एक चीज सिखाती है कि विज्ञान के अंदर नियम खोज पाना, एक कॉमनैलिटी, सूत्र, किसी भी फॉर्मूले को रटना नहीं जीवन में। इसका उद्गम क्या है, ये कैसे आया, इसका इतिहास क्या है, तभी आप हिस्ट्री ऑफ साइंस में जाएंगे। आप पहले व्यक्ति नहीं है जो विज्ञान कर रहे हैं, इंसानियत ने शुरुआत से विज्ञान करा है। उस कॉमनैलिटी को ढूंढ पाना, ये बहुत ही सुंदर उदाहरण है एक महान गणितज्ञ के जीवन का, कि जिसने रटा नहीं, जिसने रटने को चुनौती दी और जिसने कहा मैं हर चीज को समझूंगा, जब तक समझूंगा नहीं, जब तक पुख्ता बुनियाद नहीं होगी तब तक आगे नहीं जाऊंगा। और वही लोग कुछ मौलिक कर पाते हैं। बाकी ये रट्टे तोते अपना किताब ग्रंथ पढ़ते जाते हैं, ये बोझ ढोते जाते हैं ज्ञान की वो अर्थी उठा करके जा रहे हैं, अर्थी उठा के जा रहे हैं ज्ञान की, पर दे डोंट ऐड एनीथिंग टू नॉलेज। So this is a very very nice. I also want, मैं आपको एक और बहुत सुंदर प्रेरक कहानी सुनाना चाहता हूँ। ये आपने मॉन्टेसरी का नाम सुना है? मरिया मॉन्टेसरी। मरिया मॉन्टेसरी पिछली शताब्दी की सबसे महान शिक्षाविद थी, इटली में पैदा हुई थी। आपने बहुत से मॉन्टेसरी स्कूल का नाम सुना होगा, ना सुना हो तो मैं आपको उसकी कहानी छोटी सुना रहा हूं। मॉन्टेसरी शिक्षाविद नहीं थी, इटली की पहली महिला डॉक्टर थी। आप सोच सकते हैं उस समय इटली में बहुत कम, फर्स्ट मेडिकल डॉक्टर मॉन्टेसरी उसमें से एक अव्वल नंबर की थी महिला। मॉन्टेसरी ने बहुत सारे सैकड़ों टीचिंग एड्स बनाए जो आज भी 100 साल बाद में भी वो दुनिया भर में इस्तेमाल किए जाते हैं। ये मॉन्टेसरी के जीवन। और मॉन्टेसरी उस समय इटली में एक झोपड़पट्टी थी, गरीब लोग थे, तो उनके बीच में काम कर रहे थे। एक पादरी थे, चर्च का जो प्रीस्ट होता है, पंडित होता है, उसको पादरी कहते हैं। तो पादरी साहब मॉन्टेसरी के काम से बहुत प्रभावित थे और वो अक्सर उनका काम देखने के लिए आते थे। मॉन्टेसरी ने एक बहुत सुंदर से टीचिंग एड बनाई थी जिसको कहते हैं कि पोस्ट बॉक्स। अब आप समझ लिए कि लकड़ी का एक घनाकार डब्बा है, इसके यहाँ पर एक गोल कटा है तो बच्चों को एक गेंद डालनी है, यहाँ पर एक तिकोना कटा है तो बच्चों को प्रिज्म स्लाइड करना है। तो अलग अलग खांचे कटे हैं और बच्चों को तीन आयामी एक गुटका उसके अंदर पोस्ट करना है, टू पोस्ट द राइट ब्लॉक इन द राइट स्लॉट। ये मॉन्टेसरी ने पोस्ट बॉक्स 100 साल पहले बनाया था, आज भी इस्तेमाल होता है। जब प्रीस्ट आए, पादरी आए, तो मॉन्टेसरी दिखाना चाहती थी कि छोटे बच्चों की पावर्स ऑफ कंसंट्रेशन, अपने ध्यान को केंद्रित करने की कितनी असीम शक्ति होती है। मॉन्टेसरी ने, ये बच्ची 4 बरस की बच्ची इस पोस्ट बॉक्स के साथ खेल रही थी कि कौन सा गुटका कौन से खांचे में जाता है। मॉन्टेसरी ने बाकी बच्चों से कहा कि इसके विचारधारा में थोड़ा विघ्न डालो, एक गोला बना के गाना गाओ, एक नर्सरी राइम गाओ। इस बच्ची ने सिर उठा के नहीं देखा, वो अपने काम में इतनी रमी थी, कौन सा गुटका कौन से खांचे में डालती। फिर मॉन्टेसरी ने उसको उठाया और एक टेबल पे रखा और टेबल पे जैसी बैठी वो अपनी दुनिया के अंदर लीन हो गई कि कौन सा गुटका कौन से खांचे के अंदर जाता है। ये पादरी बड़े एक सहृदय व्यक्ति थे, गरीब बच्चों के साथ मॉन्टेसरी काम कर रही थी, तो कभी कोई चॉकलेट, कभी कुछ लॉलीपॉप, कभी कुछ टॉफी लाते थे और बच्चों में बांटते थे। उस दिन वो इत्तेफाक से एक बिस्किट का डब्बा लेकर के आए थे और उन्होंने सब बच्चों को बिस्किट दिया। अंत में इस बच्ची को भी बिस्किट दिया। इस बच्ची ने उसको अनमने भाव से देखा और बिस्किट को एक रेक्टेंगुलर खांचे के अंदर डाल दिया। 100 साल पहले मॉन्टेसरी ने हमको ये दिखाया कि बच्चे कभी लालच से, घूस से, तमगों से, मेडल से, सर्टिफिकेट से नहीं सीखते। जो दुनिया को समझने का जो आनंद है वो परमानंद है, वो सब इनके फीके हैं उनके सामने।
Just hold on, sir.
ये मैं आपको,
Just give me 1 second, sir. I'm coming to the point now, and just 1 minute. Okay, so sorry for disturbance. Actually, Now, after getting this motivational, a motivational small deliberation from Professor Arvind Gupta ji, now I am coming to the basics of teaching of mathematics, and then I will be coming why we are looking towards mathematics lab and how we can improve the learning of mathematics by using the mathematics lab. So definitely mathematics has always been the most important subject in the school curriculum. I'm talking about the basics now. What could be the basics? Traditional mathematics teaching has been found to be unsatisfactory. Definitely, lots of earlier we have seen lots of complaints are there about the students phobia and mathematics phobia. Such type of things are there in the mathematics. During recent years, the demand has grown to make the mathematics teaching more imaginative, creative, and interesting for pupils. Clearly, the demands made on the mathematics teacher are almost unlimited. The teacher must have a specialized understanding of the foundations of mathematical thinking and learning. She should also possess skills to put together the whole structure of mathematics in the minds of her students. Like a master technician, she should decide what kind of learning is worth what, realize and make use of motivation and individual differences in learning. Teacher's role, it comes under the teacher's role. She should be able to translate her training into practice. Finally, she should plan or design the instructions so that an individualized, discovery-oriented or problem-solving learning is fostered. Now, coming to the principles of the child development and learning, the first question is, how does one teach most effectively? This is the basic question. How does one teach most effectively? And its answer is very simple. The answer is, teach the child in the way he learns best. You have to explore what is the learning style of the child, and you have to move accordingly. Therefore, it is necessary that the teacher understands how a child learns and the factors which affect learning. Thus, the teacher has to understand the way in which growth and development affect learning. A child learns best when she is clear about the purpose or goals to be achieved. It is better if she is guided by a self-selected goal. Her purpose determines what she learns and the degree to which she learns. Children grow physically, mentally, and socially at different times and with different growth rates. Every child is different. Various growth curves giving data about height, weights, age, intelligence, and interest are aptitude inventories which apply to children of a given age group are available. We can see there are lots of data are available regarding this. However, deviations are observed mainly a time in a given group of children. The studies of Jean Piaget make it clear to us that a child's mental growth is a continuous process from birth and that his thought processes are by no means those of an adult. The thinking style of the children are totally different with the thinking style of the adult. If as an adult, if you are thinking, we are giving our reflections on some activity, it is not necessary that the children is also giving similar kind of reflections on those events. So there are difference between the thinking styles of both children and the adult. The stages of cognitive development which Piaget claims are important for the teaching of mathematics are. Piaget has claimed there are certain stages, and from the teaching learning of mathematics, these stages which we need to understand clearly. The first stage is stage 1, sensory motor operations. The first stage the Jean Piaget talked about, that the sensory motor operation, this stage lasts for about the first 18 months since birth. Actually, this is the stage when sensors of the children are developed, like what is hot, what is cold, what is near, what is far. Such type of sensors are developing in the children in stage 1. That is the sensory motor operations. Moving further, stage 2, that is the concrete thinking operation. This stage lasts until about 11 or 12 years of age. That is the up to the 12 years of age, or it differs children to children, that the student's mind are in the concrete thinking operations. I mean, when they will only think about anything when they will see in the object in 3D. I mean, in a concrete mode, in three-dimensional things. If they will see some concept in the three-dimensional thing, then only they will be able to catch or capture the concept there. So, and the third stage is talking about the formal thinking operation, that the abstract thinking operation, that this stage comes to form at the age of about 14 or 15. So why this is connected with the teaching learning of mathematics? Actually, when the students are up to in the middle stage, now foundation, preparatory, middle, and then secondary stage we are talking about, when the students are in the preparatory and middle stage of learning, their brain are up in the stage of concrete thinking operation, and our mathematics subject is completely in the abstract format. So there is mismatching between the children's thinking style and the model of the mathematics available to them. So to make them similar, what we have to do, we have to concretize our mathematical abstract concepts. I mean, in the level of middle stage, at the level of preparatory stage, the mathematics should be produced, should be placed in front of the children in the format of the concretization. We have to do most things in the concrete format, then only the children will be able to catch the concept of the mathematics. That is the requirement from the psychology point of view. This is the requirement, that the mathematics should be presented to the children in the concrete format. And because at that age itself, the students are in the concrete thinking operations only. And this is the thing why we are advocating the activities in the mathematics classroom, why we are advocating games, puzzle in the mathematics classroom in preparatory and middle stage at most. Moving further, the actual age at which each age is attained varies considerably from child to child because of the differing cultural backgrounds and environment. There is no clear borderline between the end of one stage and the beginning of the next stage, because the child's environment affects it. However, what is the important is that Piaget considers that the order in which the stages appear is fixed. I mean, the stage 1 will come first, stage 2 will come next, and stage 3 will come after that. This order is important because this order is coming with every child. And this provides a framework against which we can examine the teaching strategy. Learning is a continuous development process. It is change in behavior brought about by thinking while facing situations that call for making discoveries, recognizing patterns, and formulating abstractions or generalization in mathematics. Definitely, if someone trying to discover some concept between the activities, someone is recognizing patterns, like we have seen in the demonstration of Professor Arvind Gupta ji. He was talking about mathematics is full of patterns, and if our teaching learning style enforce the students to recognize the patterns and formulating abstractions or generalization, like whatever the thing I had discussed with in the starting with the area model, there also we are talking about the concretization of several algebraic concepts by this 3D model itself, not 3D, 2D model, you can say that. A child grows through experience which provide both security and adventure. A learner learns what he does himself. Inefficient rote learning does not cause permanent learning and results in frustration and dislike for the concept subject. So rote memorization is the main culprit for disliking the mathematics by several students. If an experience is motivating only, then it stimulates the creative faculty of the child and encourages exploration and ensures the fullest development of the child's mathematical potential. The experience should be motivating for the children. Learning by doing or the discover approach through carefully controlled situations or chosen problem has proved to be a sound teaching strategy for a highly motivating activity. A closure examination of the vast literature on mathematics learning reveals mainly 4 levels or steps of learning. There are 4 steps of learning for the mathematics. Let us see what are those steps here. The readiness. First, the student should prepare for the concept. Then experimentation. There is something for the experimentation for the children related to that concept. Then coming to the verbalization or symbolization. After the experiment, students should be able to should able to communicate about the concept, should able to verbalize the concept, or should be able to use the symbols for the concepts. And then coming to the systematic generalization. These are the 4 steps which are important for mathematics learning: readiness, experimentation, verbalization, and systematic generalization. The necessary condition leads to the acquisition of new responses are: first, real situation; first-hand experience with concrete things; intuition. While doing the experience with concrete things, the intuition will come, exploration will come, discovery through investigation, and this starts with the hands-on activity itself. Formulation, verbal or symbolic representation based on logical reasoning, and assimilation, classification, generalization, or concrete formation through thinking and reasoning. So starting with first-hand experience, it is coming the part of intuition, exploration, discovery. Then after the discovery, there is something to formulate. Formulation, verbal or symbolic representation. She should be able to communicate about the things what she had done in the activities, and in the form of mathematics, she should be able to communicate, formulate it, and based on logical reasoning. And then finally, assimilation, classification, generalization, or concept formation through thinking and reasoning. Then the concept would be formalized. New concepts are developed as an extension of previous learning. The process of learning as well as the product should be emphasized. New concepts are developed as an extension of previous learning. This is the one of the important thing. The things are connected with each other. The previous learning thing should build up the new concept. It should be realized. The process of learning as well as the product should be emphasized. The process and product both should be emphasized. Generalization in mathematics are formally inductive. Actually, if you when next we will get the time, we will talk about the inductive and deductive things also, and we will see the nature of mathematics, how the concepts are built up to which level of learning the students should based on the learning of mathematics. Generalization of the concept should based on the induction, and then how we are proceeding with the deductive things. This is also related to the 3 stages which of Jean Piaget saw, which we had discussed earlier. So the rationale behind the mathematics laboratories. So mathematics should be visualized as the vehicle to train a child to think, reason, analyze, and articulate logically. Apart from being a specific subject, it should be treated as a concomitant to any subject involving analysis and reasoning. With the introduction of computers in schools, educational computing, and emergence of learning through understanding of cause, effect relationships, and the interplay of variables, the teaching of mathematics will be suitably redesigned to bring it in line with modern technological devices. The teaching and learning of mathematics should enable the child to consolidate the mathematical knowledge and skills acquired at primary stage. Assimilated knowledge of mathematics should enable the child to solve the real life problems by developing abilities to analyze, to see interrelationship involved, to think and reasons. What are the interconnections between the concepts? They should be, the development of concepts, the previous knowledge, and the based on this previous knowledge, what the next concept is coming, and the interrelation between both the concept, it should be realized. To develop the ability to articulate logically, to develop necessary and sufficient skills to work with modern technological devices such as calculators, computers, to develop appreciation for mathematics as problem-solving tool in various fields for its beautiful structure and patterns. So, in order to develop creative and original thinking and gain practical experiences of mathematical concepts, assumptions, assertions, and rules, and appropriate communicative methods to disseminate the knowledge of mathematics was required. It provides an opportunity to, so this is the related to the mathematics lab. Mathematics lab provides an opportunity to students to understand and internalize the basic mathematical concepts through concrete objects and situations. Whatever we have seen in the Jean Piaget's concept, the concrete thinking operation should come with the execution of proper mathematics lab. And there are some serious things about using the mathematics lab. In further discussion, I will explore those points also. Mathematics lab enables the students to verify or discover several geometric properties and facts by using models or paper cutting and folding techniques. It helps the students to build interest and confidence in learning the subject. The laboratory provides the opportunity to exhibit the relatedness of mathematical concepts with everyday life. Mathematics lab provides greater scope for individual participation in the process of learning and becoming autonomous learners. It provides scope for greater involvement of both the mind and the hand, which facilitates cognition. We talk about psychomotor skills we talk about. And this is the way, this is the time when both mind and hands are working together, the cognition develops. The laboratory allows and encourages the students to think, discuss with each other and the teacher, and assimilate the concepts in more effective manner. Let us see one demo from a NCERT faculty itself, and after this demo, I will discussing about it.
Take a right circular cylinder. This is a right circular cylinder, which is object in 3 dimensions. So how to convert this physical situation into mathematics? This is our main target. So take a object, which is a cylinder having 3 parts, the upper part, the lower part, and this is the curved part. How to convert this curved part is a very difficult problem. And now open it, this curved part, and you will see that this curved part is in the form of the rectangular shape. And if it is a rectangular shape, then the question arises, what is the total surface area of this concrete object? The total surface area containing the 3 parts One is this circular. The bottom is also the circular. The area of these two circular part is pi r square, where r is nothing but the radius of the cylinder. But how to calculate the area of this curved part? This curved part has been converted into a rectangle. The area of this rectangle is length into breadth. You have opened this cylinder, along this height like this. So the circumference, which you can write it as 2 pi r, and the breadth is nothing but the height of the cylinder. This is the height of the cylinder. So we can say what is the total surface area of this cylinder. That is the area of this circular part, the area of this circular part, and the area of this curved part. Area of this circular part is pi r square. Area of this circular part is pi r square. And the area of this rectangular part, which is the curved one, which is 2 pi r h. So what is the total surface area? You can write it as the total surface area as pi r square plus pi r square plus 2 pi r h, where h is the height of this cylinder. So this is your object, and this is the height of the cylinder, h we are taking. And by mathematical manipulation, you can write it as 2 pi r square plus 2 pi r h, and this is nothing but 2 pi r h plus r in some suitable units. This is the take.
So I have just shown you one concrete demonstration that, but the thing is that it should not be teacher centric. I will come to that point. So what could be the approach we are advocating here? The mere repetition of tasks by students, whether manual or intellectual, is unlikely to lead to improved skills or keener insights or develop such innovative ideas. Just mere repetition is not allowed. Just by doing same thing, same type of activity one by one, it is not allowed. It is not advocate. We are not advocating that. Mere practice of calculating answers to predictable exercise or unrealistic world problems leads to memorization of concepts of topics of mathematics. The students to learn to think critically, analyze information, communicate scientific ideas, make logical arguments, work as a part of a team, and acquire other desirable skills unless they are permitted and encouraged to do those things time and again in many contexts. Learning often takes place best when students have opportunities to express ideas and get feedback from their peers. So that's why we are talking about peer group learning. But for feedback to be the most helpful to learners, it must consist of more than the provision of correct answers. The feedback should not only the correct answer is the feedback. Feedback ought to be analytical, to be suggestive, and to come at a time when students are interested in it. And then there must be time for students to reflect on the feedback they received, to make adjustments, and to try again a requirement that is neglected. It is worth noting by most examinations, especially finals.
Praveen, can we just conclude and take questions, because participants may have.
Within 2-3 minutes, I am just concluding.
Okay, fine. Yeah, sure.
So this is the approach we are talking about. The main thing is that I am talking about here is that it should be learner centric, not the teacher centric. Whatever the mathematics lab is in the practice, mostly the things are in the teacher centric format. And we at the NCERT level, we are talking about the activities which should come with the learner centric methods. And this we can see later on this we can. This is the things I was talking about. Mathematics learner is one of the learner centered measures. It should be there. And I'm not showing this one thing. I mean, one more activity I tried to, I was planning, but due to the time limit, I'm not able to show you these things. So again, the thing is that with ICTs, I'm talking about there is the possibility of using GeoGebra in the classrooms, and GeoGebra classroom, even just going on the website of the GeoGebra, I just show you the website only. Here you can say that classroom resources are available. Go to the classroom resources, and with any, suppose I am taking this this entire GeoGebra illustrative mathematics. Suppose I am taking this one for middle schools. I am taking this for middle stages. I have taken class 6 curriculum. So there is possibility. There is possibility that suppose I have taken the unit 1, and actually there is the possibility of once we can create classroom here itself.
Yeah, I think there is no time to create a classroom and show. We can do it separately later on.
Yes, sir. Yes, sir.
Separate
so
session on GeoGebra.
Final thing which I would like to tell you, the final thing, there are some guidelines already available with you people. If you are talking about
Here,
if you are talking about this, and you can get the NCERT Mathematics Laboratory Handbook. The Mathematics Laboratory from Homi Baba Science Center is also available. CBSE guidelines for class 9th Mathematics Laboratory in schools with lots of hands-on activities is there. In all these things you can get lots of games, puzzles, activities. In these documents you can get, and these documents are available online also. So CBSE guidelines for class 10 mathematics laboratory is also available. So these things can be used by setting up a mathematics library at the moment. So this is my conclusion. Thank you. And this is my email address. If you want to communicate any doubts further, you can write me email. You can WhatsApp me also. Thanks a lot. Thanks a lot, sir.
Thank you, Praveen. I'm sorry I have to hurry you up.
No, sir. It's fine.
The participants are given 1 hour and they may try to leave, kind of thing.
Yeah.
It's better to sort of take questions from the participants. So if participants would like to ask a question, you can unmute your mic and you can say your name and ask the question or doubt or anything you want to ask. So please go ahead. I think there is no time to just think and make a question. It's time to ask a question. So in the meantime, let me ask Praveen my question.
Yes, sir.
Before others start thinking and asking. You see, the point is, before the pandemic, we had the idea of physical math lab kind of a thing, where there used to be a designated classroom or room in the school where physical manipulatives mostly were kept, and students were given the opportunity and pleasure of manipulating things and learning with the help of a teacher. Like Arvind Gupta said in the Montessori school experiment, putting various shaped pegs in the holes, that itself was a learning experience for the kids. So, and now after the pandemic, we have switched over to mostly digital math lab you can think of.
Yes, sir.
Yeah. So, do you think now, because we are trying to go back to hybrid learning or back to classroom, actually physical classroom? So, what do you think will be the importance of software math lab and physical math lab, comparison between the two?
Yeah, in fact, sir, hands-on, there is no, I mean, there is no alternate of hands-on activities, but such type of experiences we can get in digital activities also. Like I had started with a digital activity itself. In the lecture, I had started with the activity on area concept, and it was connected from foundational stage up to the secondary stage, the concept was connected. So such type of lots of things are available on the net also. One of the most powerful mathematical software, GeoGebra, along with billions of examples are available on the GeoGebra website itself. The teachers has to, they have to build themselves to use. They have to acquaint the use of this GeoGebra. They can create the GeoGebra classroom on the website itself, and they can involve their students also in the website, and the students can perform those activities. And based on those activities, the teacher can guide them the questions, and based on the question, the students can, they can share their experiences. They can learn lots of concepts there. So definitely.
See, the question is, not all students are technological savvy. Not everybody likes technology. Even in a class of 40, there may be 4 or 5 who may not have access to technology, one, and may not like to use technology. They may like to, probably like everybody likes something, doesn't like something. So I think aren't we neglecting those students who don't like technology in this pushing digital thing too far? So that is my question. In the meantime, let us ask others if they have any questions to ask, or they have views on digital math lab versus the physical math lab. Teachers, please share your views also on that. You can unmute your mic and say something. Please, this is an opportunity for us to talk about it, talk about the process of teaching and learning. So,
hello, sir.
Yeah.
So this is Hemlata Maurya.
Yeah.
Yes, sir. Namaste, sir.
Yeah.
Sir, can we, videos of Professor Sir Arvind Gupta, are they available online? More activities we can see.
You can visit arvindguptatwice.com.
I have that site on the chat box.
Okay.
In the YouTube also, you can search for Arvind Gupta, and
Okay,
you'll find probably 100 or more videos available on the YouTube.
Okay, sir.
Yeah, so you can do that. The books are available on the link I have put in the chat box for Arvind Gupta.
Yeah. Okay.
So
sir.
that the books are available, freely downloadable. You can download and make your own things.
Yeah. Okay. Thank you, sir.
Sure. Anybody else would like to ask? Sachin, would you like to ask something, Sachin Batwal? No? Daniela, would you want to ask? We have somebody from outside India. Hello? No, nobody wants to ask something? There's an opportunity to interact with Professor Praveen Chaurasia. Wherever you may be sitting, you can always, this is an opportunity to interact. So if not, we have shared many resources. Let me formally thank Professor Praveen Chaurasia for coming over to this math clinic and enlightening us about math lab activities. I know he has a lot of things to say and a lot of things to share. He loves to share his knowledge with the teachers. So probably we'll have another session by him on a specific topic so that teachers can benefit from that. So thank you, Praveen. Thank you all the participants for coming over. Please take care. And as I was talking, time to हाथ ही चला गया है मगर पूछ अभी बाकी है. Please take care so that we come out safely and back to normal life. Thank you very much, Praveen. Thank you, everybody. Take care.
Thank you, sir.
Bye.